Okay, here we go. Area under the curve, part 1. This would correspond to lesson 2.3.1 in your book. And we're going to begin with a problem here. Estimate the area of f of x equals 2 to the x over the domain of 1 to 5 using 4 equal sections. So we didn't have to do this in the lesson today, but you're going to have to be able to do it. And that is to determine what to count by on the x-axis to make this problem as easy as possible. Okay, now the sort of easy way to do that, to figure out the width of your sections first, because that's going to help you label your graph and what to count by on the x-axis, but that's going to be our domain, okay, divided by the number of sections. So if we do 5 minus 1 equals 4 divided by 4, that means each section is going to be 1 wide. Now that's an easier type of problem, but we're starting out right now. So we can count by ones down here. Okay, 1, 2, 3. All right, and then y-axis, we just need to make sure we have enough space for everything. So 2 to the 5th power, what is that going to equal is what you have to ask yourself. Okay, so let's see here. Make sure we have enough space for everything. And if you need to reference a table, you can certainly do that. When you go to the table, you see 2 to the 5th is 32. So our graph has to go up to 32. Okay? So that's going to be a little challenging here because I only have, let's see here, 2, 4, 6, 8, 10, 12, 14, 16. So if I count by 2s, that should work. That should be 32. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay? So counting every 2. All right, now, once I have that figured out and I have my graph labeled, now I can begin the process of actually graphing. All right, again, you can use the table in your calculator for this. We're going from 1 to 5. So 2 to the 1st is 2, 2 squared is 4, 2 to the 3rd is 8, so forth. So we want to plot those points on our graph here. Okay, so 2 to the 1st is 2, 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, and 2 to the 5th is the big one there that we needed, 32. And then you can go ahead and draw your curve. Okay, now it is a piecewise function, so I'm only looking at a section of it, and that is the section between 1 and 5. Now, it asks me to use 4 equal sections to figure out this area. We figured out that the width of each of those sections is 1, lucky for us. That'll make our calculations a little bit easier. So what I would do is go ahead and divide that into the sections that you wish, so we can actually see what we're finding the area of. I use vertical lines to do that, dashed. That way I can tell the difference between my actual graph and my partitions. So I'm going to have 4 pieces here to find the area of and then add together. All right. Again, in class, we talked about a bunch of different ways to do this. We kind of let you determine what the best way was. All right, so I'm going to direct you a little more here to my way of finding this area. How can I estimate it? So what I'm going to do in this situation is I'm going to go ahead and divide these into rectangles at each of these places and find the area of each of those rectangles first. And then I'm going to add in the area of these triangles. So first, just the area of these rectangles right here, there's 4 of them. Now the nice thing is I kind of made an easy problem here for you. The width of each of those rectangles is 1. So I'm going to take the base times the height. All the bases are 1. So the height of this rectangle is just our y value. That's important for later. Okay, so that y value is 16. This y value is 8. That y value is 4. That y value is 2. So if I find the area of each of those rectangles, it'll be 1 times 16. So the area of this rectangle is 16. 1 times 8, the area of this rectangle will be 8. 1 times 4, the area of this rectangle will be 4. And then 1 times 2, so the area of this rectangle will be 2. So if I add up all my rectangles there that I made, I will have 16, 8, 4, and 2. Okay, so my total area there will be 30 by my calculation. 16 and 4 is 20, 8 and 2 is 10, 20 and 10 is 30. Now, is that the best answer? No, not yet. I would still need to find the area of each of those little triangles that I was talking about. Now, the formula for area of a triangle is a little different. It's half the base times the height. Now, it's not the total height, it's just the height from the top of my rectangle to the top of my triangle. So I'm counting by 2's here, remember? So 2, 4, 6, 8, 10, 12, 14, 16. So that's a height of 16 and a base of 1. So half the base times the height would be 8. Here, with the base of 1, height of 2, 4, 6, 8. So 1 and 8, half of that is 4. Here the base is 1, the height is 4, 2, 4. So 4 times 1 is 4, half of that is 2. And then last, half and 2, so that's 1. So I add up each of those little triangles now, and I have 8, 4, 2, and 1. Add those together, that's 10, that's 15. So my total area, or my total estimate for the area here, is going to be 30 plus 15, which is 45 units squared. Is that 100% accurate? No, because a triangle has a straight edge, and this edge is curved. Okay, so my estimate here would probably be a little high, because if I drew these triangle sections in here, you would notice that they're a little above my blue line. Okay, each of those triangle sections is a little bit above my blue line. So my estimate here, this 45, would be a little high. Okay, it's a little high. All right, but the original problem is asking me to estimate the area, so it's probably going to look something like this. The area of f of x, all right, from 1 to 5, and I would say that equals approximately 45 units squared. Now we're going to more clearly define how to find the area under a curve in future lessons, but this is part 1 of finding that area.